Alright, so welcome to my YouTube channel, and today we are going to be considering a very important topic in physics: work, energy and power. Work, energy and power. So let's start from the first one: work. Now work is the product of force and distance moved. So when we're looking at work, we're just looking at force times the perpendicular distance moved. So we can say that work is equal to what? Force times distance. So if you apply force and there's no movement, there's no distance moved, then there's no work done. Take for instance, if you carry a bag of cement and put on your head and stand in a place from today till next year, you've only done work carrying the cement from the ground to your head. But the cement on your head and standing there without moving, you've not done any work. So work is force. You're applying the force and lifting the cement, and distance. It was on the ground before, but it's now on your head. So force times distance will give you work done. So you can say the work done is the product times a product of what? Force and distance. That is work done. And you agree with me that force, the unit of force is in what? Newtons, right? And the unit of distance is meters. So the unit of work is equal to Newton meters. Newton meters. And Newton meters is same thing as joules. Same thing as joules. So the unit of work is either Newton meters of what? Or joules. So it's either Newton meters or joules. Now, what if the distance is not parallel to the applied force? When they say something is parallel, now if you look at these two lines, they are parallel to each other. What if the force you are applying is not parallel? The distance of the moving object is not parallel to the force. What I mean, if I'm pushing, okay, if I have something like this is an object. As I'm pushing it like this, the force is moving this way, and the object is also moving this way. So we can say the force and the distance moved is parallel. That's when you use this formula. But what if there is an inclination, that is, it's inclined to a plane? What if the force is inclined to a plane? So maybe I'm applying the force this way, but the object is moving this other way. All right, so if there is an inclination, if the force and the distance are not parallel to each other, but it is inclined at a plane, then what you use, the formula you use then to calculate work, is equal to F cos theta times D. F cos theta times D. So F is the applied force. The theta is the angle of inclination. So if you have something like this, this angle of inclination, that's the theta, times D is still the distance. All right, so you use this formula when there's an inclination. Then you use this when no angle is involved. Can we take some calculation under this? Okay, example 1. Calculate the work done when a bag of rice is pulled along a horizontal plane by a constant force of 30 Newton applied parallel to the plane through a distance of 20 meters. All right, so to solve this question, first of all, ask yourself, is there an angle of inclination? No, they said the force is parallel to the plane. So the parameters given, we're given the force there as what? 30 newtons. And we were given what again in the equation? Distance of 20 meters. So we're given distance as 20 meters. So you agree with me that the work done, W, is equal to force times distance, right? Which is equal to, the force is what? 30 newtons times the distance moved is what? 20 meters. So therefore, the work done is equal to 30 times 20 will give us what? 600 Newton meters. 600 Newton meters. Sorry, 600 Newton meters. And just like I said before, Newton meter is the same thing as joules. So you can also say this is 600 joules. So this is the answer to this question. So let's consider another one. A body is pulled along a horizontal plane by a constant force of 20 Newton, applied at an angle of 60 degrees to the horizontal. What is the work done in moving this body through a distance of 20 meters? Now, to solve this, you notice that we have an angle given. So the parameters given, we are given force of 20 newtons. So we're given force of 20 newtons. What were we also given? Applied at an angle of 60 degrees. So our angle of inclination of the force is 60 degrees, right? So theta is 60 degrees. What else? Through a distance of 20 meters. So we're given a distance of 20 meters. So if the distance, you can use S or D. Nobody will penalize you for that. All right, so let's visualize the equation. This is the object. You are pushing the object according to the equation along a horizontal plane. So you are pushing it this way. But the force applied is at an angle of 60 degrees. So this is the force applied, but it's at an angle of 60 degrees. Remember what I said, that anytime an angle is involved, you use F cos theta for the force. F cos theta for the force. So it means that the work done in pushing this object here, applying the force at 60 will be what? F cos theta times the distance. So the work done here will be F, force is what? We're given as 20 times cos theta. That is cos theta is what? 60. Then times the distance is what? 20. So this will be equal to 20 times the work. 20 times cos 60 is what? Cos 60 is 0.5. Then times 20. So work is equal to 20 times 0.5 will give you what? 20 times 0.5 will give you 10. Then 10 times 20 will give you 200. So we're having 200. I remember the units. Joules or watts, or you put Newton meters. So that's that for work. If you have any question, please drop it in the comment section. So let's take power. Okay, so let's look at power. Now, power is simply the rate of doing work. So power is the rate of doing work. The rate at which work is done is power. Now, if somebody is asked to clear a piece of land, two persons are asked to clear a piece of land, the same piece of land. If one person can clear that piece of land, can finish that piece of land in 1 day, and the other person was able to finish the piece of land in 3 days, who have more power? The one that was able to finish in 1 day, right? So power is the rate at which work is done. And when we talk about rates, we are talking about time involved. Time is involved there, right? So power is defined as the work done all over time taken. So power is work done over time taken to do the work. That's power. Work done over time taken to do the work. Now, we already know that work done is equal to force times distance, right? We already noted that work done is force times distance. So if we bring this into this formula, it means we'll be having power as work done now. I'll be using F times S to represent the work done now. So F times S all over what? All over T. All over T. So, and you also agree with me that, okay, let's call this one here, equation 1. And let's call this one here, equation 2, second formula for power. So this one formula for power, this is another formula for power. And another one, you notice that velocity is equal to distance over time, right? That's velocity. Change in distance or displacement over time. Anyone, displacement over time, velocity. So, and you can see that here, this S over T. So you can see that here. So we can use V to replace this. That means that power is also this. Force times velocity will still give you power. Force times velocity will still give you power. So this is the third formula we can use for power. Another one, starting from this very first formula, you will notice that, okay, let's take it from here. We already know that, or we can also continue from here because we have force here. We know that force is equal to mass times what? Acceleration, right? Force is mass times acceleration. So if we bring this into this formula, we'll be having power as MAV. Mass times acceleration for force, then times velocity. So you'll get your answer right from here. So any of this formula, you can manipulate them to get your answer. So what is the unit of power? What is the unit of power? Now from here, work is in joules, time is in seconds. So you can see that power is joules per second or watt. So is that joules per second or watt? So power is in watt or joules per second. So let's take some calculations under this. All right, so let's look at example 1. I will solve example 1, solve that together. We solve example 2 together. Then you have a classwork to do for me and drop the answer in the comment section. All right, so example 1. Example 1, let's solve it together. Say a car traveling at 60 meters per second produces a force of 400 Newton. Calculate the power of the engine in kilowatts. Now, the car is traveling at 60 meters per second. So this 60 meters per second is what? You agree with me that is the velocity of the car, right? Because meter per second is the unit of the unit for velocity. So velocity is 60 meters per second. Produces a force, so we're given force as 400 Newton. Given force as 400 Newton, and we are asked to calculate the power. We don't know the power. We're asked to calculate the power in kilowatts. But you agree with me that power is equal to work done over time taken, right? And from the beginning of this video, you saw that we said power is also what? If power is equal to work done over time taken, we said work done is force times distance, right? All over time, is it not? And we said distance over time is velocity. So it means power is equal to force times velocity. So power of the car is equal to, the force is 400 newtons times the velocity is 60 meters per second. So 400 times 60 will give us what? 2,400, right? Is it correct? 2,400. What's the unit? Newton meter per second, right? Newton meter per second. That's the unit. Newton meter per second. Newton meter per second. But now, sorry, this is supposed to be 2,000. This is supposed to be 24,000. Now, Newton meter per second, but we are asked to leave our answer in kilowatts. In kilowatts. Now, 24,000 Newton meters per second is the same thing as saying 24,000 watts. So how do you convert watts to kilowatts? To convert watts to kilowatts, you divide through by what? By 1,000. You divide through by 1,000. So 24,000 divided by 1,000 will give you the answer in kilowatts. So this will give us what? 24 kilowatts. So that's the answer to that question. That's the answer to that question. Now, example 2. In example 2, it says calculate the power of a pump which can lift 200 kilograms. So we're giving mass. We're giving the mass as 200 kilograms of a water through a vertical height of 6 meters. So we're giving the height as 6 meters in 20 seconds. So second is time, right? So we're giving time as 20 seconds. So you agree with me here? From this same formula, we know that power is equal to work done over time taken, right? And work done is force times distance all over time, right? The time is here. And we also know that force is equal to mass times acceleration, and we already have distance here. Our distance here is height, same as s, so height all over what? The time taken. So mgh all over time taken. So we look at potential energy all over the time taken. Now look at this. Power will be equal to m. We're giving m as what? 200 kilograms. So we're giving the force as 200 kilograms. So this is 200 times, we're giving, okay, let me bring this out. Power will be equal to force, we're giving m as 200 kilograms times, we're giving g. From the equation, we're giving g as 10 meter per second square. So times 10 times, we're giving h in the equation, the height, through a vertical height of 6. Then all over, we're giving time as 20. So you notice that power will be equal to, this can cancel this into this will be 10. So 10 times 10 is 100. 100 times 6 will be what? 600 watts. 600 watts. That is our answer. So the power of the pump is 600 watts. Now you're going to attempt this for me, this question for me as classwork. A woman whose mass is 70 kilograms walks up a flight of 10 steps, each 20 cm high in 15 seconds. Find the power in watts. And we're giving G as 10 meter per second square. So you're going to solve this and drop your answer in the comment section. Please, if you learned from this video, do well to like this video and share it to different platforms. That is the help you'll be doing for me. Share this video to different platforms, and also click on the subscribe button. Subscribe to our channel and share this video. Subscribe and share this video. So drop this in the comment section, and the next video I'll be doing on energy. So if you're anticipating, let me know. If you learned something from this video, let me know in the comment section. I'm Excellence Simplified. See you in our next video. Do it to like this video and subscribe. Until then, stay put.